All right, Kathryne, so your first question was, what's the generally differentiate between average rate of change and average value? Well, I'm just going to use F for lack of a function being mentioned. So whatever your function is, if I ever ask you average rate of change, that's your formula. And if you think about what that means is, if you have a function F, that's saying the Y value at the end minus the Y value at the beginning over the X value at the end minus the X value at the beginning. Bottom line, that's just a slope from beginning to end. So average rate of change, slope from beginning to end. Average value on F is basically saying, I want to average value of a function or average value of anything is I want the average of all of these. And we showed this really kind of a weird explanation if you want to go back and look through your notes where you were saying, all right, there's some value there that is in the middle, and we drew a box and we said length times width. It was got to be equal some area in between there. Anyway, it's kind of a proof we had, but that's my average value formula. So you can see they're totally different. The reason why people mess these up is if I integrate a function, I end up getting a new function, don't I? I get a new function, let's just call it big F in this case, and that new function is going to go from A to B, right? Which means big F of B minus big F of A over B minus A. And this is why people confuse them a lot. They go, oh, it's the same thing. No, it's not. Because one is average rate of change of F. I'm using F. The average value of F, I'm not using F. I'm using the antiderivative of F or the integral of F. So I'm using actually a different function. So like if I were to say the average rate, if I were to say the average rate of change of velocity, I'm using the velocity function right there. Okay. Now, if I say the average velocity, that's different, because if I say the average value of v or the average velocity, I'm integrating velocity. But what does integrating velocity give me? It gives me the position function. I end up doing change in position over change in maybe time, okay? So the bottom line is, if you ever see average rate of change of a function, slope from beginning to end. I gotta be honest with you. I have to go back and look at this because I mentioned this initially, but it's been so long since I did that. I was doing videos for you guys that first week we were out during spring break, even before spring break technically started, just to get a head start. So I went through all the AP stuff, but I'm pretty sure that area, volume, and average value were excluded from this test. But the bottom line, that's the main difference between average rate of change and average value here. Now, when it comes to number 76, you said, looking at 76, what's the difference between B and D? So I pulled this up on my, I pulled it up so I can show it in my video. But right here, when you look at B and D here, the main key is on 76, if you look at what they're asking for the derivative of P at 1. So if P is the population, the derivative would be the rate at which the population is changing, or but not the rate of change from beginning to end. I want to know the instant derivative at 1. Okay, so when I look back at B, it says the rate the population's changing, but it says on January 1st. That is on that particular date. If you look at D, D says the rate at which it's changing, but it says the average rate. So that's basically an average rate of change. And notice they had to give you a beginning to end, and they did on D. They gave you a beginning to an end. So that's talking about average rate of change, which is not what they wanted here. They wanted the instantaneous rate, which is not the average rate. Okay, so that's why I knew that I had to throw D off in that particular situation. And were you asking about anything else? Let me see. You said on number 78 is to use 0.5 as T and solve. How do I train my brain? Okay, let me look at 78. I should have looked at that ahead of time. 78 says the rate at which motor oil is leaking is defined by that. How much oil leaks out for the first half hour. Okay, so you said Hold on now. Solve for L of 0.5. Oh, well, remember what we talked about? The problem with that would be L is a rate, and the question says how much, not what is the rate at 0.5. So if you were to do L of 0.5, you're finding the rate at which motor oil is leaking out. You got to remember, we talked about when you integrate a rate, you get a change in the amount. So if L is the rate at which the oil is leaking, then the integral of L is the amount of oil which is leaking. And that's what you're asked for, right? How much oil, what amount leaked out? So that's why I have to integrate this. Now this would be a calculator question for you guys. I mean, there's no calculator on there, so they would have had to change this formula for your AP test to something you can actually integrate. Maybe make it just like sine of t or sine of 5t. That you'd be able to integrate. You can't integrate that. You can't do a U substitution that works. But anyway, yeah, you got to get, that's going to be a big topic, I'm guessing. But when you integrate a rate, you get a change in the amount. And that's what I was asking for. Okay? All right. Hopefully that helps. If it doesn't, just text me back and I'll try to find another way to communicate it. See you.